Hi, welcome back. In this mini lecture, we'll be talking about psychology as a science, chapter 1. Our learning objectives for this mini lecture are to define and describe the study of psychology, to demonstrate why common sense may be misleading, to summarize how scientists overcome their biases, and to explore how to think like a scientist. So first, what is psychology? I want you to take a moment to think about this. How would you define psychology? You might be having a hard time coming up with a definition of psychology, and this is because psychology is actually pretty difficult to define. But for the purposes of this course, we'll define psychology as the scientific study of behavior and mental processes. The key word here is scientific. Psychology is a science, as will become clearer in this mini lecture and throughout the semester. Now, psychologists are committed to understanding not only human behavior, but also animal behavior. Now, a lot of people believe that psychology is simply common sense. So common sense being the way that we intuitively understand the world. And this isn't true. Like I already mentioned, psychology is a science. Also, common sense is frequently incorrect. And we tend to trust our common sense because we're prone to what's known as naive realism. So naive realism is the mistaken belief that we see the world as it really is. So basically, you walk around the world, you look around, and you think that what you see is actually reality. It's actually the way that it is. But that isn't true. So we'll watch a brief video clip here that kind of illustrates naive realism.
Excuse me, you don't know where Trinity Church is, do you?
Might be Wall Street and Broadway.
Okay. Well, we're down here somewhere, aren't we?
Yeah, you see Trinity Church.
Oops, sorry.
Sorry. Yeah. Inside the Trinity Church right there. Yeah. If you keep going that way, you'll hit Broadway, then you go down a couple of blocks.
Okay.
And
Thanks very much.
That seemed almost too easy, so later on I see how far I can take it.
Excuse me, do you know where Trinity Church is?
It's in that direction.
Okay.
Yeah.
Last time I switched with someone who looked a little bit like me, but where's the fun in that?
Excuse me.
You know who best direct you? The other side. You see where that lady's standing?
Sure.
That's the booth. No, the lady in the gray.
The other side.
Yeah, the other side of the booth.
So you don't know where it is?
Exactly what street? No, but it's in that direction.
Okay.
Yeah. Okay.
Thank you.
So this video clip is actually a really great example of naive realism. Just think about it. You're taking a walk, someone asks you for directions, you give them directions. You think that that's reality. You think that you only gave one person directions. But in the case of this video, that isn't true. What people believed that they saw is that they only gave one person directions, and that's not reality. So remember, naive realism is the mistaken belief that we see the world as it really is. Now, I don't want you to toss common sense out the window because common sense is sometimes true. Our intuition can be quite accurate, and it can help us to generate hypotheses that scientists can later test rigorously. So learning how to think scientifically teaches us when to trust our common sense and when not to. So for example, look at these two tabletops. Which one of these tables is longer? So in other words, is this line longer? Or is this line longer? And if you're using a computer that isn't distorting this image, you'll actually think that the tabletop on the left is longer, but really when you measure these two lines, they're exactly the same length. So again, psychology is a science. And science isn't a body of knowledge, it's an approach to evidence that's designed to prevent us from fooling ourselves. So the scientific theory is a general explanation for a large number of findings in the world. It offers an account that ties multiple findings together. And good theories do more than just account for existing data. They generate predictions regarding new data that have not yet been observed. Testable specific predictions are termed hypotheses. In psychology, and in all science, we must abandon relying on opinions. Instead, we have to find out which explanations best fit the evidence or the data. So sometimes you'll encounter information throughout this semester, and you'll be able to think about an example that contradicts this concept that I'm presenting, let's say, or you might just have an opinion that you disagree with it. But what I'm presenting to you here is based on scientific evidence. So for the purposes of this class and any scientific class, you really do have to abandon relying on your own opinions. We're gonna base things on evidence. So testing a hypothesis can lead to scientists to accept a theory that generated the hypothesis, to reject the theory outright, or to revise it. So there's kind of like a chicken and an egg situation going on. So let's say that we're starting with a theory. So remember, a theory is a general explanation of a large number of findings. We're using this theory to make a prediction. That prediction is known as your hypothesis. Then you're going to design an experiment to test that prediction. Now keep in mind that the experiment is not the only type of research design that you can use to test a prediction or a hypothesis, and we'll talk about some of those next. But we're going to stick to experiment for here because most of you have heard of experiments. So you're going to perform the experiment, and then you're going to make observations. Based on your observation, based on the evidence or the data that you've collected, you might create a new theory, you might modify a theory, you might or you might completely reject the theory. And just like all other humans, scientists have biases. So in order to protect themselves against biases, researchers use the scientific method. The scientific method is a system for reducing bias and error in the measurement of data. It provides some sort of safeguard against errors and biases. And the scientific methods are tools for overcoming confirmation bias. So confirmation bias is the tendency to seek out evidence that fits your beliefs, but then to completely ignore any evidence that doesn't fit those beliefs. So for example, you believe that your favorite football team is much better than your friend's football team. So you only pay attention to the times that your favorite football team beat your friend's favorite football team, and you completely ignore all of the times that your friend's football team beat your football team. Everyone is prone to confirmation bias. I want you to start thinking about this as you move through your life. So scientists need to design research studies that may contradict their hypotheses, because if scientists only design studies that support their hypotheses, then really that research study isn't telling us very much. Confirmation bias predisposes us to belief perseverance. So belief perseverance is the tendency to stick to our initial beliefs even when the evidence contradicts it. Okay, so basically you have all the evidence that your favorite football team actually isn't the best, but then you still stick to your belief that your football team is the best. Keep in mind that not everything can be assessed using science. Some things fall outside the boundaries of science. So for example, metaphysical claims fall outside the boundaries of science. These are claims that can't be tested. They're non-testable assertions that fall outside the realm of science. So examples of these are the existence of God, the existence of the soul, and the existence of an afterlife. Now, I'm not saying that we have to completely disregard these claims. All that I'm saying here is that these claims fall outside the bounds of science. You can't test these scientifically. It doesn't mean that we're not going to respect these claims. It just means that we cannot test them scientifically. Now, keep in mind that even if a claim can be tested scientifically, and then you test the claim, and then your claim is supported by the evidence, that evidence might actually have pointed you to the right direction. So it's still possible that your claim is incorrect even if you found support for your claim. This is why good scientists never say that they prove their theories, or at least in psychology, we don't say that our theories are proven. We say that we found support for our theories. We need to distinguish science from its imposters. And one imposter of science is known as pseudoscience. So pseudoscience is a set of claims that seem scientific, but they aren't. Pseudoscience lacks the safeguards against confirmation bias and belief perseverance. Pseudoscience can be tested scientifically. They're just not supported by the evidence when they are tested. So some examples of pseudoscience would be fortune telling, astrology, and telepathy. So take a moment to think about what the difference is between a metaphysical claim and pseudoscience. Can you figure out the difference? The big difference here is that metaphysical claims cannot be tested scientifically, whereas pseudoscience can be tested scientifically. There are some warning signs that can help you distinguish science from pseudoscience. I'm only going to give you a couple today. One is the ad hoc immunizing hypothesis. So this is basically an escape hatch to protect against falsification, usually some sort of loophole or exception for negative findings. So for example, you go to a psychic and you're trying to test whether or not psychic powers actually exist. And you find out that the psychic is just completely wrong. Now the psychic can use an ad hoc immunizing hypothesis. It's some sort of loophole. And the psychic can tell you, actually, you're skeptical of my psychic abilities, and your skeptical vibes are interfering with my psychic powers, right? So now this hypothesis isn't necessarily wrong, but it makes the psychic's claim essentially impossible to test. It's some sort of loophole. Another warning sign of pseudoscience is the over-reliance on anecdotes. So anecdotes can't tell us about cause and effect, and they're often very difficult to verify. So for example, Step 1, apply miracle cellulite cream to problem areas. Step 2, run 10 miles. So you see a commercial for this miracle cellulite cream, and the anecdotes you'll hear is, this miracle cream really worked. But what caused the miracle cream to work? Is it actually the miracle cream, or is it that you ran 10 miles? So in conclusions, learning to think scientifically teaches us when to trust our common sense and when not to. Psychology is a science, which is an approach to evidence, and science seeks to find out which explanations best fit the evidence or data. Also, acknowledge that you have biases, just like all other humans, that can get in the way of scientific thinking.